Evaluate integral 0 to infinity e to the power minus t square into this one. Okay, so here like in the previous means the 2 days back the lecture we had. So I need to find out, this is a particular case of that property which we did yesterday. So here if I write L of t square minus 3t plus 5 plus e raised to 2t t square, this is equal to integral 0 to infinity e to the power minus st ft dt. So what is ft? This is your f of t. Okay, so by definition we are going this by definition, e raised to minus st into ft. Ft means t square minus 3t plus 5 plus e raised to 2t t square dt. Okay, so now what we have to do here is, so this is by definition of Laplace transform, equation number 1. Now what to do is, you will find this one, you will solve the answer of this one, means you will solve this one, and what answer you are getting in that answer, instead of s, what you have to put here, it is minus t, e raised to minus e to the power minus t. So s is 1 there. So what answer you are going to get on solving this LHS, in that answer you will be putting s is equal to 1. Property of Laplace transform, that is when you multiply a function of t with t, then this Laplace transform, when we apply the Laplace transform, it converts to, or it changes to the differential of that s function. Okay, so if L of f of t is f of s, then we multiply f of t with t, then that is equal to minus d by ds, first derivative of f of s. Similarly, if you multiply f of t with t square, then you need to do 2 times derivative, means d square s by ds square. So 2 times second derivative you are finding, and here minus 1 raised to n. Actually this is done by the process of mathematical induction. Okay, the proof is given by the process of mathematical induction, but we do not want that proof, so I am not telling the proof here. Similarly, if L of t cube f of t is minus 1 raised to 3, d cube upon ds raised to 3 f of s, and in general you can write that as L of t raised to n f of t is equal to minus 1 raised to n d raised to n upon ds raised to n f of s. Okay, so this is the concept of multiplication by t in Laplace transform. Find Laplace transform of, simple one we will do, t into sine 80. Okay, t sine 80. That means we have to find here L of t into sine 80. So here this is f of t is sine 80 and this is t. Okay, so t into sine 80. So first of all you have to find out L of f of t. So look at the formula here. If L of f of t equal to f of s, so first of all you need to find the Laplace transform of that f of t. So here f of t is this function. This is your f of t. Okay, so that is L of sine 80. L of sine 80 is equal to, by formula we know it is a upon s square plus a square. L of sine 80. Okay, therefore L of t means we multiply that with t. T into sine 80 is equal to, what will come there? Minus d by ds of, minus d by ds of f of s. So this is our f of s. Okay, L of f of t equal to a upon s square plus a square. So that is in terms of s. So that is our f of s. So L of t into sine 80 will be minus, because here only one t is there. So for one derivative only. Minus d by ds of this f of s. F of s means a upon s square plus a square. So just find the derivative of this. We will get the answer there. So on differentiating this one, you will get it as 2as upon s square plus a square the whole square. Sorry, here whole square. U by v formula you can apply there, or take a common, a constant. This is a constant, so take it out and then you can simplify it. 2as upon s square plus a square the whole square. L of t e raised to minus 2t sine t. So first of all you have to start with, see here you will apply for shifting property and the normal one. L of sine t you will write, then in that one you will apply the first shifting property, then in that one you will apply multiplication by t property. Okay, so here First of all, you will write L of sine t. Then in that answer, you will apply first shifting property. So L of sine t we will write. Then L of e to the power minus 2t sine t. Then in that answer, you will apply multiplication by t property. So t into e to the power minus 2t sine t. So just do this. Equal that. So first of all, we will solve here under root of 1 plus sine t. So that is under root of 1 plus sine t. What we do here, it is under root of this 1 will be replaced by sine square t by 2 plus cos square t by 2. Because sine square theta plus cos square theta equal to 1 plus this sine t. Sine t we will write it as 2 sine t by 2 because we need to remove square root from here. So we are doing like this 2 sine t by 2 cos t by 2. Okay. So 1 we have written like this sine square theta plus cos square theta and sine 2 theta. Sine 2 theta is 2 sine theta cos theta. Using that formula we wrote sine t equal to 2 sine t by 2 cos t by 2. So that is equal to, if you look at here, this is of the form a square plus b square plus 2ab form. A square plus b square plus 2ab, which is a plus b the whole square. So this will be under root of sine t by 2 plus cos t by 2 the whole square. So square root of sine t by 2 plus cos t by 2 the whole square, and this we know under root and square is there. So we have here sine t by 2 plus cos t by 2, right? So that square and root it is there. So it is sine t by 2 and cos t by 2. Okay. Then this is equal to, therefore now we have to find out, therefore L of t, we need to get L of t into square root of 1 plus sine t. We need to get this one. Okay. So here first of all what we will do, we will find Laplace transform of this 1 plus sine t, under root of 1 plus sine t. That means that's equal to L of sine t by 2 plus cos t by 2. Okay. So that is equal to L of sine t by 2 cos t by 2, that is equal to, this is equal to sine a is 1 by 2 here. So 1 by 2 upon a square plus a square. A square means 1 by 2 square. Then plus here it will be s upon a square plus a square. So a square plus a is 1 by 2 square. A square plus a square. Then that is equal to 1 by 2 upon, just simplify a little bit, 1 by 2 upon, this is s square plus 1 by 2 square is 1 by 4 plus here s upon s square plus 1 by 4 again. So that is equal to s square plus 1 by 4 is common denominator upon numerator is 1 by 2 plus s. So on that day we did it. So here taking 2 as LCM. So this will become, that will become as 1 plus 2s. Okay, taking the LCM there. So it is 1 plus 2s. And denominator divided by what will come here, 4 is LCM here. So this will become 4s square plus 1 whole divided by 4 will come. So on that day we did this. That's why I am going in this way. That means a simplified form I am writing here. So I hope all of you remember this one. Okay, so 2 into 1 plus 2s upon 4s square plus 1, or in short we can write this as 4s plus 1. 4s plus 2. I hope you remember this. Okay, so that is 4s plus 2. This will be 4s plus 2. That will be the simplified form of this one. Means already you had this one. I think we did it once or twice. Okay, so just simplifying that one, you will get it as 4s plus 2 upon 4s square plus 1. This is what L of under root of 1 plus sine t. Okay, then that is equal to, now therefore L of t into under root of 1 plus sine t is equal to minus d by ds of what will come 4s plus 2 upon 4s square plus 1. Yeah, Anas has done the problem. So very good. So all of you solve this now and get me the answer. So L of sine 80, as you know, it is a upon s square plus a square. Then here it is L of t square sine 80 is here. L of t square sine 80. So if you remember the first formula, what formula we have given here? It is if L of t into f of t means when it is t here, when it is t here, here it is minus d by ds. One time you are finding the derivative. When it is t square here, when the power is 2, we are finding second derivative 2 times. When it is 3 here, it is t cube, we are finding 3 times derivative. Same way in general, when it is n here, we are finding nth derivative. Okay, so here we will have to find out, means it is t square is given. In the question it is t square. So what we have to do here is, it is minus 1 raised to 2 d square upon ds square of this f of s. This is our f of s. So it is a upon s square plus a square. Okay, so that is equal to minus 1 square is minus positive 1. Then now we need to find the derivative of this 2 times. So it is d by ds of a upon a square plus a square. 2 times we need to get the derivative. So that is d by ds of, now one time derivative already we had in the last problem, answer of this one. So here it is a is a constant, then it will be 1 by s square plus a square the whole square. Means what I am doing is derivative of 1 by x form. Derivative of 1 by x is minus 1 upon x square. Okay, so here derivative of 1 by s square plus a square, here is a constant, a is a constant, and this is x. In place of x you have s here. So it will be, its derivative will be minus 1 upon s square plus a square the whole square, then derivative of this s square plus a square. So that derivative will come. That is the way I am doing. Otherwise you can use u by v formula, that is, that I will show that too. U by v formula if I use here, so constant is here, then d by ds of 1 upon s square plus a square. So this both ways you can try, either this way directly, or this is a bit lengthy, this one what I am going to do. So it is a into d by ds of, now if you use u by v formula here, then denominator, this is s square plus a square, denominator into derivative of numerator. Derivative of numerator means derivative of 1 is 0, minus numerator 1 into derivative of this denominator, it is 2s, and derivative of a is 0 upon denominator square, s square plus a square the whole square. So those are good at this differential equations or differentiation, they can go by this way. Okay, if you do not know this one, then direct formula, just apply the formula and you will get that. Okay, so that is a into d by ds of, here this total, this becomes 0, and numerator it is minus 2s upon s square plus a square the whole square. Then again this is equal to, 2 is constant, a is here, so I will take minus 2a d by ds of s upon s square plus a square the whole square. Now find the differential of this one and tell me the answer. Derivative of s is 1 here, minus, now numerator means here s into derivative of this denominator. So derivative of that denominator will be, this is of the form x square form. Okay, so derivative of that s square plus a square the whole raised to 2 will be 2 into s square plus a square raised to 2 minus, means this is x square, derivative of x square form. Derivative of x square is, you know, it is 2x raised to 2 minus 1 and x raised to n minus 1 form. So it is 2 into s square plus a square the whole raised to 2 minus 1 into, now derivative function of function rule. So derivative of s square plus a square will be what? Derivative of s square is 2, s will come. Okay, so this much terms will be there in the numerator divided by denominator square. S square plus a square square the whole square. So denominator, that means this denominator into derivative of s is 1 minus numerator s into derivative of denominator. It is 2 into s square plus a square into derivative of this inner function. S square plus a square derivative is 2s divided by denominator square. Okay, so that is equal to minus 2a, this is common for all, into s square plus a square the whole square minus, now see here, 2 into 2s into s, this s, so I'll just use this s we will take, then 2s you will take, and this 2 you will take. Okay, all that 3 together, we will take there, so that is s into 2 into 2s, so that is 4s square, 4s square into s square plus a square. Okay, 4s square into s square plus a square divided by this denominator, that is s square plus a square the whole raised to 4, because here 2 into 2 it is 4, that is equal to minus 2a into, now if you look in the numerator here, s square plus a square whole square, here one s square plus a square is there. Okay, so I'll take that one s square plus a square common, so s square plus a square common into here remaining now s square plus a square. From here, from this 2 you took 1 outside, so 1 is remaining there, minus 4s square, and we take this outside, this s square plus a square is outside now, divided by s square plus a square the whole raised to 4. Now what we can do here, this s square plus a square 1, and here it is 4 is there, so we cancel that one, and we got it as minus 2a into s square. Now see, s square minus 4s square, so s square minus 4s square will become minus 3s square plus a square divided by s square plus a square the whole raised to 3, or that's equal to, just take this minus sign inside, or we don't want to keep this negative outside, so I'm taking it inside, so it is 2a into, what will get, 3s square minus a square upon s square plus a square the whole cube. So this is the Laplace transform of t square sine a t. Okay, so as the power of t increases, when t is 3, you need to do it 3 times. You need to differentiate it 3 times. So for exam, normally you don't have more than 2 and all. Maximum you will have this t square type only. So their differentiation is very important. I hope most of you got this answer. Okay, if you haven't got, just check that signs and all. Here e to the power minus t cos h2t. So first of all you write cos h2t. So all of you may think that we will write L of cos h2t, then in that one you will apply this for shifting and all. That's okay, but it can be done even better than that, easily than that. Okay, so what I'm going to do here is, first of all I will find what is cos h2t. Cos h2t we know it is e raised to 2t plus e raised to minus 2t divided by 2. Okay, this is cos h2t. So now e raised to minus t into cos h2t. The other way is also okay, but I think this is simple one. So it is e raised to minus t, e raised to 2t plus e raised to minus 2t divided by 2. Okay, so cos h2t, we wrote that simplification or the exponential form of cos h2t, and then e raised to minus 2 in minus t into cos h2t is this one, or this is equal to 1 by 2. Now just multiply this inside. E raised to minus t into e raised to 2t is e raised to t, plus here e raised to minus t into e raised to minus 2t will be e raised to minus 3t. Okay, this will be a simplified form. It means you can do it a little easy. Now L of, what we will do, L of e raised to minus t cos h2t will be equal to L of 1 by 2 e raised to t plus e raised to minus 3t. Okay, then this is equal to 1 by 2 constant. L of e raised to t is 1 upon s minus 1 because we know L of e raised to at. L of e raised to at is 1 upon s minus a. So here a is 1. T. Here only e raised to t means a is 1. So it is 1 upon s minus 1 plus here e raised to minus 3t means 1 upon s plus 3. Okay, so that is Laplace transform of e raised to minus t cos h2t. Now what we have to find? We need to get L of t into e raised to minus t cos h2t. So therefore L of t into e raised to minus t cos h2t will be minus d by ds of, so this is our f of s now, so it is minus d by ds of 1 by 2 into 1 by s minus 1 plus 1 by s plus 3. Okay, so this is equal to, now 1 by 2 into minus 1 by 2 derivative of each term, derivative of 1 by s minus 1, derivative of 1 by s minus 1, this step you can avoid, plus derivative of 1 by s plus 3. Okay, now that's equal to minus 1 by 2 into derivative of 1 by x. Derivative of 1 by x is of the form minus 1 by x square. So minus 1 by s minus 1 the whole square, plus here also again my derivative of 1 by x form. So that also again it is minus 1 by s plus 3 the whole square, right? Or that's equal to minus 1 by 2 into all throughout here minus, here also minus sign is there, so we take the negative sign outside, so minus into minus becomes plus here 1 by 2 into 1 by s minus 1 the whole square plus 1 by s plus 3 the whole square. Okay, so here you can leave it, no need to simplify this one. Okay, so directly suppose you were doing here itself if you are doing, here itself if you are doing cos h2t, cos h2t, suppose you write like this, L of cos h2t, we know it is s upon s square minus a square form, so s square minus 4, then here you will apply what, when e raised to minus t is here, this s will change to s plus 1 and all, that is also another method to solve this one, but it will be lengthy and a bit complicated, means you need to use a lot of formula, I mean a lot of steps there. So this step, this method what I did, this is easier than that. Okay, so simplify it.